Hello everyone and welcome back. So let's continue our discussion about improper integrals furthermore. Now what do we have here? We have 1 over cubic root of 3 minus x to integrate, and that function is discontinuous when x is equal to 3. However, the difference here is that the point that this function is discontinuous, that means 3 is not the lower limit or the upper limit of the integral. Actually 3 is in between the bounds of the integral. The bounds of the integral are 2 and 5, right? That means you are integrating this function between 2 and 5, and the function is discontinuous at 3, which make this integral an improper integral. But however, this integral is different from previous integrals that we saw in the previous videos, because the point that's discontinuous is not in the lower limit or the upper limit of the integral. So how are we going to evaluate this improper integral? Because if 3 was the lower limit or the upper limit, we know how to solve it. Okay, now what are we going to do here? Think about this. Now we have to integrate this function between 2 and 5. Right? So I can rewrite this integral in another way. That means what I'm going to do is I'm going to first integrate this function from 2 to 3 right here, and then I'm going to integrate this function from 3 to 5, and then I'm going to add both of them. Then it's same as integrating the entire function from 2 to 5. Okay, it's the same thing. It's just I'm going to split the integral into two separate integrals. Okay, so first I'm going to integrate the function from 2 to 3. Okay, so the same function cubic root of 3 minus x, 1 over cubic root of 3 minus x, and then I am going to integrate the same function from 3 to 5, which means the same thing. Okay, it's just I am solving the integral like in two steps rather than integrating it by one shot. I am going to do it in two-step process. Okay. Now what's the advantage of splitting this integral into two parts? The advantage is that now you can see the point that this function is discontinuous is actually the upper limit of the first integral, and it is the lower limit of the second integral. Now what can we do here? Well, we can now adopt the idea of taking limit and solve these two integrals separately using the techniques that we saw in the previous video. That means, what do I mean? Well, here I am going to replace 3 by a letter t. Okay, in the integral the function is 1 over cubic root of 3 minus x. I am going to take the limit, okay, when t goes to what? T goes to 3 from what side? From left hand side. Okay, so that's how you write the first integral. Plus now the second integral, I am going to replace 3 again by a letter. Okay, so let's replace it by t, and you are integrating from t to 5, 1 over cubic root of 3 minus x. Now again we take the limit. However, now limit t goes to 3, get close to 3 from the right hand side this time. Okay, now you can see this is how I write the second integral using the limit. Right, now this is the common trick. When you have the discontinuity in between the bounds of the integral, you have to separate, you have to split the integral and make sure the point that the function is discontinuous appears in the upper limit and the lower limit. Then use the techniques that we learned in the previous video. Alright, so from here on it's just we need to evaluate these two integrals. Let's see, what can we do? What can we do here? Well, to evaluate this integral, we have to use integration by substitution. Okay, let me show you why. Now, here my substitute is going to be, I am going to choose my u to be 3 minus x. Now, since u is 3 minus x, du over dx is derivative of 3 minus x is minus 1. So, that means du is actually minus dx, or you can say dx is minus du. Alright, so we need both of them when we use integration by substitution in both of these integrals. Okay, so let's write when limit t goes to 3 from the left hand side. Here now the integral is 1 over cubic root of 3 minus x, which means cubic root of u. Cubic root of u can be written as power of u, power 1/3 power of u. Okay, cubic root means power of 1/3. Okay, and here instead of dx, now you have minus du. Now you can do the same for the second integral, because basically you are just integrating the same function, just the bounds are different, right? So it's actually minus u 1/3 du. Okay, all right. Now we have to change the bounds of integral, because previously we were integrating with respect to x. Now we are integrating with respect to u. So we have to change the bounds of x to bounds of u. So how are we going to do that? Well, 2 here. So when x is equal to 2, what's u? So 3 minus 2 is going to be 1. So here it's 1. Now when x is equal to t, what's u? Well, it's actually 3 minus t here. So we have to change the bounds. Now when x is equal to t, u is 3 minus t, and when x is equal to 5, 3 minus 5 is negative 2. So we change the bounds of the integral from x to u. Okay, right. Now here on, it's just evaluating the integral when limit t get closer to 3 from the left hand side. So to help with the integration, I am going to rewrite negative 1 over u to the 1/3 in a different way. I am going to take u to the 1/3 into the numerator. So when I do that, it becomes u to the negative 1/3. Okay, and plus limit when t get closer to 3 from the right hand side, it's you are integrating from 3 minus t to negative 2. I am going to do the same. I am going to rewrite this function as minus u negative 1/3. Right, now it's easy to integrate from here. So limit when t get closer to 3 from left. If you integrate negative u negative 1/3, you just add 1 to negative 1/3 and divide by negative 1/3 plus 1. Now you have to evaluate this function at 1 and 3 minus t, plus here limit when t get closer to 3 from right. Here it's the same thing, negative u negative 1/3 plus 1 divide by negative 1/3 plus 1. You are evaluating the function at 3 minus t and negative 2. Okay, so let's find some space. Great. Now it's just we need to simplify. So let's first simplify before we take the limit. Okay, so here it's minus negative 1/3 plus 1 is 2/3. Dividing by 2 over 3 is same as multiplying by 3 over 2, right? So I can write here as 3 over 2. Plus now limit t goes to 3 from the right. Here it's the same thing, negative 3 over 2 u to the 2 over 3. You have to evaluate it from, you have to evaluate it at 3 minus t and negative 2. Here you have to do the same, 1 and evaluate at 1 and evaluate at 3 minus t. Okay, so let's do the evaluation. So limit when t get closer to 3 from the left. Now you evaluate the functions. First let's evaluate u at 3 minus t. So it's minus 3 over 2. Instead of u, you have 3 minus t. So 3 minus t to the 2/3. Now minus, that means subtraction. Now you evaluate the function at 1. So that means negative 3 over 2, 1 to the 2/3. Okay, that's done. Now this part. Okay, so this is a little bit long, right? So limit when t get closer to 3 from the right. Let's see, first evaluate the function at negative 2. So negative 3 over 2, negative 2 to the 2/3. Subtraction. Now evaluate the function at 3 minus t. Minus 3 over 2, 3 minus t, 2 over 3. Okay, nice. Let's see whether we can simplify this furthermore or not. So limit when t goes to 3 from the left. So it's negative 3 over 2, 3 minus t to the 2/3. Here negative negative plus 1 to the power 2/3, it's actually 1. So it's plus 3 over 2 here. Okay, at least that was nice. When t goes to 3 from the left, this is going to be, well, unfortunately we cannot simplify this furthermore. Okay, so negative 2 2/3, so we can keep it there. Here negative negative plus, so this is 3 over 2, 3 minus t to the power 2 over 3. Right, finally we have simplified everything. Let's take the limit. Okay, all right, so let's see what happens when t get closer to 3. 3 minus t, what's happened when t get closer to 3? This number is very close to 3. 3 minus 3, well, the difference is very small, right? So this is going to approach to 0. So this is going to go to 0, because this in the numerator it's going to be 0. 3 subtract by a number very closer to 3. When t get closer to 3, it's going to be 0. Okay, here also the same thing. T approaches to 3. Okay, so 3 minus a number very close to 3, it's getting smaller and smaller. The difference is getting smaller and smaller. That means it's approaching to 0. So that approaches to 0. So limit of a constant is constant. So the limit of 3 over 2 is, well, actually 3 over 2, plus limit of this term is actually that term itself. Okay, so let's write the answer. It's 3 over 2 minus 3 over 2 negative 2 to the power 2 over 3. Now this is the limit, and this is a real number. Okay, so you are taking the cubic root of negative 2, which is not an imaginary number, by the way. Okay, so this is a real number, and since this is a real number, the limit exists and it is finite. Definitely this is a finite number, so this integral converges. Okay, so this is a convergent integral. But the big takeaway of this problem is that when you have the discontinuity in between the bounds of the integral, you split the integral into two integrals such that the discontinuity appears on the upper limit and the lower limit of the integral, two integrals, and then from there on treat them as two integrals and use the techniques that we learned in the previous video to solve the problem. It's basically you are solving two problems, two integrals. Okay, all right, so what we have to do from here on is to solve more and more problems from improper integral lesson. So in the next video I'm going to solve more problems. So hopefully catch you there. Bye bye.